Okay, so how's things, guys? So we'll have a look through the paper 2, 2024 higher level. Um, Easy enough exam, just like the paper 1. So we'll have a look through that now. So just the first question here, handy enough, just on about mode, range, and median stuff. So we'll go through this. So first thing is asking what should the mode be if what would A be if the mode is to be 34? Well, if your mode means most common, if you want 34 to be the most common number, there needs to be 3 34s, so A would have to be 4. Okay, because you see there's 2 57s, stuff like that, and you don't want you want there to be a clear mode winner, so there needs to be 3. Now the range question below is a little bit more interesting. So the way to think about the range is it's the max minus the min value, but because they're like a B and C here, the max value looks a bit like 60 plus C, and then that's take away the lower value, which is like 20 plus B. Because if B was 3, then that number is 23, and that's 49. So that's only one equation and 2 unknowns, so you can't actually solve this. So I'll just write it out. So it's 40 plus C minus B plus C minus B equals 49. And then we get that C minus B equals 9. But if you think about this, B has options. B can either be 0, 1, or 2, and C can either be 8 or 9. Now the only way you're going to get 9 from C minus B, there's only one way it can work, and it's if C is the 9 and B is the 0. So there you go. So you can have a think about that if you want. So B is 0, C is 9. Right, that's that. Then the next question then is on the median. Median of the data is 43.5. So the median formula, that's where you go like a half n plus 1, and n for this is 22. So that works out as 23 over 2, and then that says 11.5. So that means you get the 11th added to the 12th and divide those by 2, like such. So the 11th number from my counting, because there's 8 up to there, 9, 10, this is 11, this is 12. So it's like 40 plus D plus 45 over 2 equals the median value of 43.5. 43.5. Okay. Yep. And then you multiply across by 2, and then take away the 95. Just double confirm. Take away the 85. And D works out as 2. D is 2, and so that number there is 42, but D's value is 2. Okay, it's fine, it's fine. So we'll clear that away. Yeah, that was fair enough first question, bit of thinking in it, so it's a good balance. So this is an interesting one here as well. So for B here, initially looking at it, I'd say I describe that as a sort of exponential relationship. Okay. And then you could just describe, it looks like it's fitting an exponential. As the initial test values were bigger, there was an exponential growth for this. So if you can describe that, like that's fine. But you can also say it's it looks like a straight line correlation as well. Particularly the latter few there. And then you'd say it's it's a positive correlation, and it's a pretty strong correlation. And so we work out OR later on here, and you can see this helps. So you type those into your calculator using the y equals a plus bx mode, and you get an OR value of 0.9145. And if you're getting an OR there, that's a very strong positive correlation, and you could even use part of that as your answer up here. So yeah, those points actually do follow a straight line quite well, particularly if you ignore that point there, you can see that they do. Okay, so any sort of reasonable stuff. Question 2 is very easy, and they're making things a little bit too easy when they're telling you what makes things a fair game, you know, that's sort of stuff students expect to know. So the expected value for this question is 0 multiplied by 0.3 plus 2 euros times 0.4 plus x minus 10 times 0.28 and then plus x times 0.02. And all that then is equal to your expected value of 10, which they tell you in the question. You do all that out there, you got 0.6 plus 0.8 plus 0.28x minus 2.8 plus 0.02x equals 10. And you can see that you're getting from that, a little bit of room here. Okay. So from that you're getting that there's a 0.3x and the numbers on this side give, what's that there? 0.6, 1 second, let's confirm. Yeah, that's not I don't know where I got that 0.6 from here. That's just 0. 0 times 0.3. Yeah, absolutely. So that's 0.3x, and then you take away 2 when you tot them all up, and you get 10. So then 0.3x equals 12. So then x equals 40 euros. And what you can do then is you can, you know, set this as 30 and set this as 40, and then work out the expected value. Then you'll see that that it works good. So yeah, x is 40 there. Okay. Cool. So B here is a good question. It's fair enough. Just checking do students know what this is. Mutually exclusive. The diagram for mutually exclusive is two circles that don't intersect. And so their intersection has a value of 0, and then the union for them just adds up. You just add them up. So it's just kind of check and see if you knew what the diagram looked like. Okay, that's good. C and D are two events. So this is a good question. It's kind of a junior cert question. This gets commonly asked at junior cert. So what you do is you draw a diagram for this. You draw your two circles, your C and your D. Now you mark the inside with an X, and then you mark, because C is 0.5, you mark this as 0.5 minus X. And then that's the same with this one. This is 0.7 minus X. Now, all this region out here, the important region out here, is 1 take away those guys added up together. So if you add them up in your head, you see it's 1.2 minus X plus X minus X. So it's 1.2 minus X. So that outer region there then works out as minus 0.2 plus X. So that region out there is described as they say in the question there, the probability of C union D not. And the biggest possible value that thing can have is dependent on the X, and X can't have a bigger value than 0.5. See, because then C would be negative. So X has to be 0.5 to maximize this. So if X is 0.5, then the answer to this thing here is 0.3. So your diagram, so 0.3 is the answer. So your diagram, the final diagram looks a bit like this. You have your C, you have your D. There's nothing out here. There's the full 0.5 in the middle there. And then there's 0.2 here and 0.3 out here. So yeah, put the X in the middle. Do some smart stuff after that, get that answer. Okay. So it's fair, it's all fair. This is also a fair question. So they wouldn't be independent because it raining will, so this, you could put this in words, it raining will make you more likely to want to wear a coat, and that's the definition of dependence, that F's probability changes depending on whether or not E is happening or not, and that'll get you full marks. That's completely fine, nothing wrong with that. You can do a little bit more then on that. So you can sort of state that probability of F given E, you don't have to do this. So F given E has happened is actually more likely, so its value is greater than probability of f given E naught, you know. So in other words, the probability you wearing the coat if it's not raining is less than if it is raining and you wear the coat. And so, you know, for independence, probability of f given E has to be the exact same as probability of f given E naught, and which has to be the same as probability of f, you know, it just doesn't change. And that's, as you can see, not the case here. But again, you don't have to do that. You just use the words. Okay, parallelogram, easy enough question here as well. Sketch up a parallelogram with this. So I drew A down here, B here, drew C up here. Okay, D. I marked this in as 10, marked this in as 13, marked this in as 110, like such. So to get the area of this, split it down the middle like that, and then I got the area of this triangle here and doubled it. So the area of that triangle is half AB sine C. And sure, if you're going doubling it, you could just say the area is AB sine C. And so that then is equal to 10 times 13 sine 110. And when I typed that in, I got 122.16 cm, which was 122 centimeters squared. Okay. And next part in question 3 was also very fair. You know, these come up all the time, literally like every second year. So anyone that was prepared would have known how to do these. So what's your cos here? Your cos is a positive angle, so that occurs in this region and this region because of your cast diagram. So you always go cos inverse the positive thing first. And that gets you your first quadrant angle. That works out as 30 degrees. And so that's him there. And so the other quadrant angle is 330 degrees because the rule for that quadrant is 360 minus theta, where theta is your first quadrant angle. So what you do then is you split your page down the middle. Set the angle, which is the 2x, equal to your angles, which is 30, which is next one is 330. You add on 360n. This is questions all in degrees, you see. Plus 360n, and it's at this stage then you divide by 2. 15 plus 180n. 165 plus 180n. Then you let your n be 0. You get x to be 15 degrees. You get x to be 165 degrees. You let n be 1. You get x to be 195 degrees. And you let n be 1. You get x to be 345, was it? 345, yeah. And the great thing is you can sort of move on from this knowing that there's no need to let n equals 2 because your angle will get too big then, you know. But you can just put those 4 back in there for x and then they'll work out as that. So you can always move on from this knowing you got the 4 right answers or whatever. Right, that's all cool. So part C then here, this is grand. It's just making a diagram of this. That's all this was. So how did I draw this? I put a point there, there, there. Call this K. Call this L, and I call this M. I then said that this here is 15 root 3 from the question. This here is 45. And I think it's this here, yeah, that was the 25 degrees. And then this here is the unknown LKM, yeah. You use your sine rule on that. You're looking for theta, so you'd have the theta on top. Sine theta over 45 equals sine 25 over 15 root 3. So then your sine theta equals 45 sine 25 over 15 root 3. And then you do your sine inverse on that. Inverse on all of that. And it works out as 47 degrees. Now, sine, according to the unit circle, is positive in this quadrant and this quadrant. CAST. So your other solution is this quadrant, which is 180 minus theta. And so the other answer here is 133 degrees. Cool. So it's like they call that the ambiguous case. You're using the sine rule, and there's two possible triangles. So that's come up before in an exam. Right, construct the centroid. It's fine as well, nothing major here. So let's have a look. You have to do construction for this, so you need to get the midpoints. So what you do is you put your pointed part of the compass there, you'd swing an arc here, put the pointed part there, swing an arc there, join those together, and then you're going to get the midpoint, you know, say there, something around there. You do that for another side, say you get the midpoint there, and you only need to do this for two sides, and the way you get the centroid then is by joining the opposite vertex to the midpoint, opposite vertex to the midpoint, and then that where those two red lines intersect is the centroid. You see they're in a ratio of 2:1 as well. Okay. This down here, this is literally just a proof from your tables book or from your textbook. This is one of those like learn off proofs, so anyone who learns it off will be sound. It goes where you like draw a line parallel. There, you make a parallelogram. So you draw this line here, and I'm sure that's the same as that. Well, we don't know they're yet, so then those angles are opposite, vertically opposite. So then these then are like this, and then third angle must be the same, so similar triangles. But then they're congruent then because of the sides matching up, you know. So anyways, that's a perfect proof for anyone who learns it off. Okay. So circle here, very soft first question here to get things going on the circle. So what do we have there? Write down center. Center is -2, 3. Radius is square root of 4 plus 9 minus 5. G squared plus F squared minus C. That works out as, get it here, move on to the right page. 2√2. 2√2, yeah, so that's about, what's that there, √8, isn't it? Yeah, 2√2. Okay. There's another equation here. Prove that these two fellas touch internally. So if they touch internally, the distance between their centers, this distance here, will be equal to the big or big. Take away or small. So the radius of this guy, we'll just get the distance between their centers first. This guy's center is 2 minus 1. This guy's center was -2, 3. Distance between 2 points formula, square root, you can label the points up however you like. 2, take away this point, +2, plus squared, plus -1, -3 squared. And I got that to be 4√2. And then the radius of this guy here, when you do √72, √72 is 6√2. And sure, this guy's radius was 2√2, and you just do a little thing for the examiner where you go, you sub into this formula here where you say, what was the distance? The distance was 4√2 equals or big, which was 6√2 minus 2√2, and you just say something like true, you know, in turn. Okay, easy enough. Moving fairly quick through it. And this is also a nice question. So best way, we know the center's x value, but we want a bit more than that. So best way to do this is to create something called a perpendicular bisector, which goes through the midpoint of these guys here, and it's perpendicular to the pink line, so it goes a bit like that. Not drawn very well, a bit like that, and that will go through the center of the circle. So all you got to do is sort of do a simultaneous equation here. The equation of this line here is x equals 9. It's a vertical line. I just need to create the equation of that green thing there. So what you do is you get the midpoint first. The midpoint of those two guys is 7 plus 12 over 2, comma 10 plus 8 over 2. So the midpoint works out as 19 over 2. So try keep these out of decimals, you know. 19 over 2, 9. Better to use fractions. What you do then is you get the slope of the pink line, which is sort of like 8 minus, what did I do? Yeah, 8 minus 10 over 12 minus 7. And that works out as minus 2 over 5. So then the green line slope is perpendicular, so the green line slope is 5 over 2. 5 over 2, yeah. So I'm just seeing here, I done a mistake there in the thing I call it 2 over 5. So the rest of that calculation mightn't be correct. So what I'll do is I'll just push ahead anyways with this. So that's minus 2 over 5, yeah. And then green line's 5 over 2. So then the equation of the green line is y minus y1, which is 19 over 9. So creating the equation of the green line now, y minus y1, m times x minus x1, 5 over 2 times x minus 19 over 2. And then you multiply across by the 2 here, so you'll get something like 2y minus 18 equals 5x minus 19 by 5. So that's 95 over 2 minus 95 over 2 because we've sent the 2 over there, you know. Yep, and this has an x beside it. So then you have 5x minus 2y minus 95 over 2 plus 18. We got minus 59 over 2 equals 0. So that's the equation of the green line, and all you got to do is let the x equal 9 in it. So if you let x equal 9, you'll get something like 5 bracket 9 minus 2y minus 59 over 2. So I'll just quickly do this and hopefully my calculations work out alright. And to get the y value, so let's type it out into my calculator. Try to get it right. So y equals 5.9 over 2. I'm getting about 31 over 4 there. So then all I need now is the radius, and then you get the radius from just getting the distance from your newly found point, which is your newly found center, which is 9, 31 over 4, and get the distance from that to any of the points, say like 7, 4, 7, 10, and that distance there works out as, just doing it quickly here, be something like, you know, 7 minus 9 squared plus 10 minus 31 over 4 squared. Just quickly get a value for that. The method is what's important, you know. So the distance there is working out as root 145 over 4. And so the equation of the circle then is x minus 9 yeah, squared plus y minus 31 over 4 squared equals 145 over 16, something like that. Okay, so hopefully, as I said, that works out. But anyways, the method, the perpendicular bisector is the way to go. There's other ways to do it, but that's a nice quick way. Now, this one here, two ways to do this. You can use the formula in your tables book for this, or you can use a translation. Translation gets it very quickly. So what I'll do is I'll use the tables book formula and the translation to show you both ways. So just draw a little diagram of this first. So marking the points, doesn't have to be to scale. A, C in the middle, B. A's coordinates were 113. C's coordinates were 611. This guy's unknown, x, y. They are in a ratio of 1 is to 3. So you have a formula in the tables book for this, and it goes a little like this. So you'll have your 611, which is the middle point, would be equal to 3 bracket 1 plus 1 times x, so I'm just literally subbing into the formula in the tables book, over a plus b, which is 4, comma, 3 times 13 plus 1 times the y over 4, and then you set 6 equal to this thing here, the x part, and you set 11 equal to the y part, and you'll get your x and y, and your x and y work out as 21, 5 would be the correct answer there for anyone who got it. Okay, so I'll show you how to use the translation. So if you work out what the sort of delta x is, call it delta x, the movement for the first step A onto C, that was equal to 5. The delta y was 13 onto 11, which is minus 2. That was one jump. You just do 3 times that jump. So the new delta x will be a 15, and the new delta x will be a minus 6. This is like the translation. So you add 15 onto that, you get 21. You take 6 away from that, you get 5, and you get the point again, 21, 5. Okay. Right. Find the perpendicular distance from that to that. So easy enough, the formula for that in your tables book. So maybe multiply across by 3 first. 3y equals 4x minus 33. 4x minus 3y minus 33 equals 0. Okay. Yeah. And then your point is this. So the distance formula says modulus a times the point, so 4 bracket 5, plus b, which is the minus 3, times the minus 2 up there, the y, and then plus the c, which is minus 33, all over the square root of, it's like 4 squared plus 3 squared. They're being squared anyways, and the bottom works out as 5, And the inside there, just confirm it again. So 20 plus 6 minus 33. Yeah, it's a 7 in the modulus, so there's a 5 in the bottom. So a minus 7 in the modulus, so it goes positive. I got 7 over 5 there. Right. This next one is a bit funny, for sure. The part 2 is tough. Part 1 isn't. How many different pairs can be picked from the 16 points? So there's 16 points. Choose 2 at a time. 16, choose 2. Have I done? Yeah, 16, choose 2. I'm looking at the next part. 120 pairs, okay? So that's fine. Yeah, there's 16 to choose from. Choose 2 of them. Right. The next part's tricky, so it's like the 2 points that are picked are joined with a straight line. Find the probability that line is horizontal. So I've identified 2 ways to do it, and just in the sort of, I'll add in the comments which way is correct later. So I haven't fully made up my mind on which one it is. So I said I haven't spent enough time to think which one's correct. So one way of doing it is, and it's probability as well, so I'll show you what has to go on the bottom there. Right. One way of thinking about it is there's 16 points. Let's just pick one of them for the minute. 16, choose 1. Just pick any random point. And let's say we picked and landed on this point. That means then there's just 3 more points I can pick from to make my straight line. So it's a bit like 3, choose 1. And then you divide that then by the probability of, by the number of ways of just doing this, which is 16, choose 2. And then that works out as 2/5. Now the other way is what if we say, right, we want a horizontal line. So that means we need to kind of choose which row we want the horizontal line on. So do we want on this row, or whatever? So I kind of go 4, choose 1, pick one of the rows. And now say you pick this row, it can pick it, land on any row. There's 4 points there, choose 2 of them to make your line. And then divide that then by your 16, choose 2. So that works out as a 5th for me. And one of them is correct and one of them isn't. So I said I have to have a little bit of a think about which one is the more correct one. But look, you could spend all day on this question here, and it's probably only going to be worth 5 marks, because look at how many parts there were in this question here, 30 marks. That'll probably be, poorly enough answered. If you get anywhere near thinking through a value like this, you might get 3 marks or whatever, So yeah. So all good. So yeah, I'll add a comment on which one's more correct. And you can also add your own comments on what you thought. Now, right, so we'll do the long questions here. So I'll break this up.